All right, Algebra 1 students, let's look at our continuation of section 6.6. We are looking at exponential functions, and related to that, we were looking at what are called geometric sequences. Remember, I told you that we really have been talking about geometric sequences all along as we were talking about exponential functions. So they are very much related. Remember, I said that as an exponential function, as x values increase, the y value increases very rapidly. So remember, we looked at, we'll start at 0. So for the exponential function y equals 2 to the x, when x is 0, 2 to the 0 power is 1. When x is 1, 2 to the 1 power, 2 to the first power is 2. When x is 2, 2 squared is 4. When x is 3, 2 to the third power is 8. And this is increasing exponentially. You are multiplying by 2 every time to get to the next y value. So we've been doing this all along, and now all you're going to be given is just the sequence of, you could say, y values here. And you're going to notice that there is a common ratio, meaning a common number that you're multiplying by in order to get the next value in that sequence, in that list. Okay? So we are going to pick up here on practice A. If you would, take out your 6.6 practice A, and we are going to continue there. We're going to pick up at number 7. And what this is saying is the graph down here, is it showing an arithmetic sequence, a geometric sequence, or neither? And all you need to do is you need to look at how it is changing. So you'll notice here that the y values are going from 1,000 to 500 to 250 to 125. They are being halved. You are multiplying by a half here every time. So your base in the exponential function would be a half. This would be like y equals 1/2 to the x power. That is an exponential function, and it's what we would call a geometric sequence because you're multiplying by something in order to get the next y value. So this is definitely geometric. Okay? Geo. I'll just put geo here. Number 8. Number 8, notice what's happening here. For every time that x goes up by 1, 1, 2, 3, 4, the y values are increasing steadily by a particular difference, a set difference or a sum that you're adding. 7 to 13, that you get that by adding 6. 13 to 19, add 6. 19 to 25, you add 6. So here you're going up 6 every time you go over 1, up 6 over 1, up 6 over 1. That has a consistent increase or a consistent slope. That is linear, and the sequence of numbers here, the sequence of y values, would be called an arithmetic sequence. Okay? So this is arithmetic. Okay. In number 9 and 10 it says write the next 3 terms. So we have to recognize what the pattern is. We are told that they're geometric sequences. We just have to recognize the pattern. So let's look here. We need to figure out what are we doing to go from 3 to 15, and then from 15 to 75, and 75 to 375. Hopefully you notice that you are multiplying by 5. Okay? Multiplying by 5. So, to get the next values, you are going to take your calculator, next 3 terms, you're going to take 375, multiply by 5 to get the next number, and then take that number and multiply by 5 to get the next number. and then multiply by 5 to get the third number after the 375. You can do that with your calculator. Number 10. Number 10, again, we are trying to find the next 3 terms in the sequence. As soon as you see that the numbers are changing signs, this is going from positive to negative, you know that your common ratio has to be negative in order to switch the signs. And you'll notice that the numbers are decreasing. That means you're going to multiply by a number less than 1. The magnitude is less than 1. So if you look at this, this is being divided by 4, or in other words, multiplied by 1/4. So 1024 times 1/4, or divided by 4, is 256. 256 divided by 4 is 64. 64 divided by 4 is 16. So you're multiplying by 1/4, and it has to be a negative 1/4 because the signs are changing. So let's continue that pattern. You're going to take negative 16 and multiply by a negative 1/4 to get that next number. You can do that. It's like dividing by 4. So if you want to divide by a negative 4, it's the same thing. That's going to give you 4. And then to get the next number, you divide by a negative 4 or multiply by a negative 1/4, and you're going to get negative 1. And then to get the next number, you're going to do the same thing, and you would end up getting a positive 1/4. Okay? Now what we're going to do, this is kind of new, we're going to write the equation. But it's not really new because we already have been seeing these exponential functions. It's going to be in this form right here, like this. Okay? So we have been seeing y equals a times b to the x. We've been seeing this already. This is an exponential function. This is your base. This is your initial number. That's the starting value when x is 0. And this is your exponent, or that's how much you're counting by. That's the x, and it's going up by 1, 2, 3, etc. Okay? And this is the value of y that you're looking for. So this, we've already seen this, and we're just going to add to it as we talk about these geometric sequences. Let me go back up to our example right up here. And let's build this equation from just the data. So you'll notice here, ladies and gentlemen, I'm going to write this equation as y equals 1 times 2 to the x. Alright? It's the same thing as 2 to the x. 1 times 2 to the x. So notice, when x is 0, y is 1. That right there is your starting number. Okay? When x is 1, you get 2. That number right there. So you'll notice that when x is 1, you get this value right here. That is your base. Okay? But it's the second number in the sequence. Alright? So it's the second number in the sequence. So if I want to get the third number in the sequence, this is the third number in the sequence right here, I'm putting in 2 for x. Because I started at 0, I'm putting in 2 for x, and I'm getting 4. If I want to get the fourth number in the sequence, I'm putting in 3. So these x values up here, what I really am going to kind of change this to be the number in the sequence. So instead of x, I'm going to start putting n. And n is going to be the first number in the sequence, the second number in the sequence, the third number, and the fourth number. Notice that this n is 1 greater than the x value was. This is 1 greater than the x value. So I need to adjust by subtracting from this x value. Okay? So here's our general formula for these types of equations. It's going to be y equals, or actually I'm not going to use y, I'm going to say a sub n, and that is just any number in the sequence. A sub n equals a times b to the n minus 1. And I will tell you exactly what you need to put in here. Okay? It's real simple. So this is our general formula for any geometric sequence. Geometric sequence. And I'll show you how easy it is to come up with it. Okay? So in order to write the equation, we look at the numbers that are given to us. This is called your sequence. And we're just going to put it right into this formula right here. So this is kind of like, remember, see how these are similar? Y equals a sub n equals a times b to the x, b to the n minus 1. And actually, I'm going to change this b to r because that's our common ratio. So really the formula is going to look like this. A sub n, that's like your y, equals a, and I'm going to put a sub 1, that's going to be the first number in the sequence, times r, that's our common ratio, to the n minus 1. So we already, everything in this formula right here, you're going to have in the sequence or be able to find in the sequence. You'll know the first number, you can find the common ratio, and then you'll have your formula. Okay? So let's look at number 11. Here's how easy it is. You take number 11, you start with our formula, and all you're going to do is you're going to put the first term, the first number in the sequence right in there for a sub 1. Here it is. We're doing number 11. Sorry, number is 3. So a sub n equals 3 times, and now we got to find the common ratio. In other words, 3 times what gives me 6? 6 times what gives me 12? 12 times what gives me 24? You should see that we're multiplying by 2, right? If you don't see that, take 24 and divide by 12. You'll get 2. 12 divided by 6 is 2. 6 divided by 3 is 2. That is our common ratio. So this is 2, and then to the n minus 1. That's your formula right there. Let's see if it works. Let's just double check if it works here. Watch. This is like your x and your y. It's just written as n and a sub n. So when n is 1, the first number in the sequence is what? Well, put 1 in for n. 1 minus 1 is 0. 2 to the 0 is 1. 1 times 3 is the 3. Let's put in 2. The second number in the sequence, put in 2. 2 minus 1 is 1. 2 to the first power is 2. 2 times 3 is 6. You see, we're getting the same values right here. The third number in the sequence, the third number is going to be 3 in for n. 3 minus 1 is 2. 2 squared is 4. 4 times 3 is 12. And you can see that we're getting all those numbers right there using this formula. Okay? Let's look at number 12. Oh, I think we were asked to find the sixth term. That's what this means. A sub 6 means find the sixth term. So a sub 6 means the sixth term. All you do is you put 6 in for n. 3 times 2 to the 6 minus 1. What does that give us? Well, 6 minus 1 is 5, so we need 3 times 2 to the 5th. 2 to the 5th is 2 times 2 times 2 times 2 times 2. That's 32, I believe. So 3 times 32 is going to give us 96. Okay? Let's do the same thing over here. All you do is you plug it right into the formula. A sub n equals a to the first, a sub 1, that means the first term, times the common difference to the n minus 1. And I can find, all you have to do is put in these two values, the first term and the ratio. You got to put in those two numbers. The a sub n is part of the formula, and the n is part of the formula, just like your y and your x. So my first term is 0.375. And what's going to be the common difference? Well, you take any number in the list and divide by the number before it. So I'm going to take 24 and divide by 3. That is 8. So my common difference is 8. And I'm going to take that to the n minus 1. Okay? Now it says find the sixth term. Remember, we're going to find a sub 6. So the sixth term means I put 6 in for n. 0.375 times 8 to the 6 minus 1. And now you take out your calculator and find out what 0.375 is times 8 5 times. You can do that on your calculator. Okay? Okay, same thing here, number 13. Here's the first term. Here's the second term, third term, fourth term. I hope you see that you are multiplying by, see this decimal point moves over 1, 2 places. 1, 2 places. 1, 2 places to get the next number. You are multiplying by 100. Okay? Multiplying by 100. So your formula is going to be, it's the same thing every single time. You need to tell me the first term. It's right here. It's given to you. 0.0124 times r. What's the ratio? It's 100. What are you multiplying by? 100. And to the n minus 1. I'll just put these in parentheses just so it's a little clearer. Now, if you wanted to find the sixth term, put 6 in for n. So that would be 0.0124 times 100, 6 minus 1 times. That's 5. 6 minus 1. So you got to take 0.0124 times 100 5 times. 14. Okay, as soon as I look at this, I see a couple things. First of all, you notice that the sign is changing from negative to positive, negative to positive. And the numbers are going down. The magnitude of the numbers are going down. So my common ratio has to be negative, and it's going to be less than 1. The magnitude will be less than 1. If I want to figure out what it is, it's real easy. I could take 2 divided by 16. That's 1/8. You can see that you're dividing by 8 here, right? Or you're multiplying by 1/8. So my common ratio is negative. Remember the signs are changing? 1/8. And here's my first number in the list. All I do is a sub n. That's like your y equals. And my first number is negative 1024 times r. My r is negative 1/8 to the n minus 1. All you have to put in is the first number and the common ratio. And now we use this formula to find the sixth term. If this kept going, we would want to find this one right here, the sixth term. So a sub 6, the sixth term, would be negative 1024 times negative 1/8. Put 6 in for n. 6 minus 1 is 5. Now you need to take out your calculator and take negative 1024 times a negative 1/8 5 times. Okay, we're going to look at a few applications here, 15 and 16. Number 15. It says a digital city map displays an area of 544 square units. After you zoom in, the area is 272. After you zoom in a second time, the area is 136. You see that the area is getting smaller and smaller, right? So we have to figure out how much, by what factor is the area being reduced every time you zoom in. So it says, what is the area after you zoom in 5 times? Well, you could find out what this number is that you keep multiplying by. Well, that's easy. Remember, you could take any number in the sequence. Let's write out the sequence here. It's going down. 544, 272, 136, and that's going to keep going. And we want to find out the 5th one. Okay? So we got to figure out what we're dividing by, or what fraction we're multiplying by. Remember, it's easy. Just take any number and divide by the number in front of it. So if you take 136 and you divide by 272, you're going to get 0.5, right? 0.5. All right? So you're taking half. You're halving everything. So then I'm going to halve this again. You got to take half of 136 and take half it again. Or you could use your formula. A to the 5th power is going to equal, or a sub 5, not to the 5th power. A sub 5 is going to equal the first number, 544, times 1/2. Use 0.5 if you want. To the, I want to find the 5th one, so it's going to be the 5 minus 1. So 544 times half 4 times, and that will get you your answer. Okay? All right, and number 16 here. Number 16, what is the 8th term of the geometric sequence where that is equal to that? So they're giving you the 2nd term. Notice this is the 2nd term, not the 1st term, and this is the R value. That's the common ratio. If this is the 2nd term and you multiply by 5 to get 20, then the 1st term must be, that's right, 4. Okay, the 1st term must have been 4 because the common ratio is 5, and 4 times 5 gives me the 2nd term. So now it says, what is the 8th term? Well, you could, if you want to, just keep multiplying by 5. Here's the sequence. We started with 4, we found the 1st term. Then it's 20, multiplied by 5, you get 100. You multiply by 5, you get 500. You can keep going, or you can use the formula. So what's our formula? To find the 8th term, a sub 8, I take the first number in the list, a sub 1, and I multiply by the common ratio raised to the, I want to find the 1, 2, 3, 4, 5, 6, 7, 8. I want to find the 8th term, so 8 minus 1. So I have to take 4 times 5 7 times. And that will give me the 8th term in my sequence. Okay? Alright, I'm going to pause there, and the next video we'll pick up with 6.6 practice B and finish that one up.